All right, let's take a look at sum and difference formulas. So what we're talking about here is when we're asked something like, give me sine of some angle plus another angle inside. And they're not going to give it to you explicitly in the sense like you'll get like, give me sine of 15 plus 30, right? That we could just do. So this is in cases where it's not defined, we're using variables. So at the heart of this, we'll go to the little more cleaned up version of this, but essentially what's going to happen is you're going to have a 90-degree triangle created where we have x, right? That's the first angle we're trying to deal with. Then this up here is going to be x minus, or I apologize, 90 minus x, right? If this is 90 degrees in the bottom right, and this is x, we know that the whole thing must equal 180 degrees. Well, then there was only 90 degrees to split between these two angles. Therefore, x and 90 minus x would equal 180 degrees. And we can see that. X plus 90 minus x equals 90 degrees. The x's cancel out. 90 equals 90. Check. Good to go. Now, for our y angle, then, we're going to have a triangle like this. Right, so this is our y angle right here. And this is going to be a right triangle as well. And again, 90 minus y would be here, but I will show you why in a moment, why that's not really going to be relevant in this case. What we're going to do here is we're going to essentially say that the y triangle is touching the unit circle via the hypotenuse. What that's going to do for us is the hypotenuse is going to be 1, the base is going to be cosine y, and this right here is going to be sine y, right? We're talking about the unit circle, the x is cosine, and the y is sine, right? So we can just say cosine y and sine y, and then the hypotenuse is 1 all the way around the unit circle because that's just the radius. So what we're going to do now is we're going to extend this line, right? We're not going to actually do it. We're going to pretend we're doing it, if you will. So we've got this green line right here that extends all the way down and creates a larger triangle with our x angle. Okay, so when we have this 90-degree angle right here, as we extended this line, this is also a 90-degree angle. With that being said, if this portion is 90 minus x, that means that this portion must be x. Okay, so if we can visualize that, let's draw a line down from this corner, and then let's redraw this triangle that we've just created on the right side so that we can really call out what's happening here. Okay, so we had a line coming up here. Okay, a right angle there, a right angle there. Okay, and then this we just said was x. This one was x as well, right? Because if this was 90x, 90 minus x right here, and this is a 90-degree angle, then this must also be x. That also means this, right? If we extend here, what we've done is we've split this larger triangle, and again, we'll draw it a third time right here without any of these cuts. this angle right here must be congruent to this angle. Okay, so this angle right here. This angle all the way up here must be congruent to this one, which is also the same as this angle. And then they're all 90 degrees. So all three of these are similar, right? When we use a perpendicular line to cut these triangles, or cut this triangle rather, when we do that, the triangles end up being similar, right? Doesn't matter. This angle is 90 degrees. That angle is going to be right there, and this one is going to be congruent as well. So what we can do with that information is we knew what the sides were when we were talking about the y-angle triangle. We do not know the sides and length, or so the sides and height of the x-angle triangle, right? It does not touch the unit circle, so we can't just say cosine and sine. Doing this, what we just did, enables us to call this angle x as well. Now we have the ability to put that in reference of this sine and cosine, which is valuable to us. So we're just going to, again, extend that line over, right? We need to make those two triangles. We need this one right here, which is why I just put that purple line right there, and then we've already created this one in green, which would be right here. Okay. With that being said, let's go up to our more cleaned up version of this. So if we're adding these two x's and y's together, that is actually saying is we're going to have this angle right here, this x and this y. To find the sine, you need the opposite over the hypotenuse. Well, the opposite is going to be h1 and h2 put together. We don't have those yet. Over 1. We can solve for this h1 and h2. Now, you may have noticed this. This h1 is the same height as our side of the x-angle triangle, or rather the height of it. So when we do sine of x is over opposite over hypotenuse, we can say that it is h1 over cosine y. And that is what we have down here. Now we solve for h1 by itself by multiplying cosine y by both sides. And we have that value. So we have the blue portion. Now we need the purple. And this is where creating those two other triangles comes into play, right? We can't use that x in the bottom left to find h2, but we can use the same x up top. So to do that, we're going to take the cosine of x is h2 over sine y, right? Take this adjacent over hypotenuse. Multiply both sides by sine y, and we get h2 by itself. Now recall that we said that sine x plus y is equated to h1 plus h2 over 1, or opposite over adjacent. Now that we have h1 and h2, we add them together. And we use the same logic to find the difference. So we don't want to write this formula twice, once for adding angles, once for subtracting. So we just make it consistent and say that the sum difference formula for sine is sine x plus or minus y equals sine x cosine y plus or minus cosine x sine y. Now this isn't like the quadratic formula. You don't do both things. You don't find it for plus and minus, right? You just do the one you're doing. So if you're doing plus, you choose plus for both. If you're choosing minus, you choose minus for both. In this case, and we'll see why I said that in a moment when we take a look at cosine. If we're trying to find the cosine of x plus or minus y, well, again, let's just start by looking at the positive case. We'll worry about the negative case a little bit. We're going to do the adjacent over the hypotenuse, right? In this case, it's going to be the widths now, not the heights. So we have width 1, but instead of adding these two together, that doesn't really make sense. we only need this green one all the way up to where we meet this height. So what we actually need to do is we need to subtract the green width by the red width. Right? We're actually going to do subtraction to find our adjacent side to our newly formed y and x angle. Okay, so how do we do that? Well, we're going to basically take a similar strategy. The cosine of x is w1, the green, over cosine y. When we do that, we can multiply both sides by cosine y to get width 1 by itself. Just like we did with the other one, we can't really use the bottom left to find the W2. We have to use our newly formed one at the top of the triangle, this x up here. We're going to take the sine of x is equal to W2 over sine y. Let's go back down. We multiply both sides by sine y to get W2 by itself. Now recall that we are not adding these together, right? We have this total width and we need to subtract the portion of what we do not need. So cosine x plus y is equal to cosine x cosine y minus sine x sine y, right? We're taking what we, the total and subtracting what we don't need. And we use the same logic to find the difference formula. And in our conclusion, we find that the sum and difference formula for cosine is cosine x plus or minus y is equal to cosine x cosine y minus plus sine x sine y. No, we did not make a mistake. You are seeing this correctly. It is cosine x plus or minus y, but on the other side it is minus plus. You need to pay attention to these signs in this formula and understand where they come from and why we differentiated between the same signs on both sides for the sine and opposite signs when we were talking about cosine. Now, what about tangent? Well, if we recall that tangent is sine over cosine, we're just going to take these two things that we found, right, for the sum difference for sine and the sum difference for cosine. We're going to put them over each other, right? So this looks really convoluted at the moment. There's a lot of extra noise there. So what we're going to do is we're going to try and clean it up. We're going to try and create only tangents all throughout. Right, to do that, we need to get sine over cosine with the same angle being represented. What I noticed is that we have a sine x here, right? So I would need to have a cosine x on the bottom. Okay, so we start there. And then I have a cosine y next to it. Now, I can't make a tangent with a cosine in the top. So here, I mean, you can manipulate it as is, but for me, I decided to try to eliminate it, right? I'm going to put a cosine y in the bottom. So I'm going to multiply by 1 over cosine x cosine y to make a tan x and then eliminate the y angle entirely in this little first portion right here. And I'm going to see what happens to the rest of this thing when I do so. What I find is that the first term cancels out to be tan x. The second part of the top, the numerator, is going to cancel everything out to become tan y. All right, so this is working out well. We have to multiply the bottom, what we multiply the top by. When we do cosine x cosine y over cosine x cosine y, well, that's a term divided by itself, and that's just 1 minus plus, and then it looks like we're going to get both tangents, right? Tan x and tan y. This is, in fact, the sum and difference formula for tan. So, with that said, that should do it for our sum and difference formulas.